All right, some of you have been having questions about how's Mr. Brewer grade, what's going on with my tests, and what sort of things I'm looking for on the test as far as how do you get full credit. Okay, I'm giving you an example problem for your next test, something that you might see on your kinematics. So the question asks, police find skid marks 22 meters long on a highway showing where a car made an emergency stop. Assuming acceleration was the negative 10 meters per second, how fast was the car going? Part one of the question. And then part two, was the car exceeding the 80 kilometers per hour speed limit? Okay, so first things, we probably need to write down, what do we know? So when we write our givens, what's given in the problem, you get points for that. If you don't show anything, I don't know how to tell you that you can get points. Okay, so what we want to do here is go step by step. They find skid marks 22 meters long. So our distance traveled is 22 meters. Okay, so we write that down. So distance equals 22 meters. On the highway showing where a car made an emergency stop, so it's stopping. So we know our velocity final equals 0 meters per second. Assuming we're going to stick with meters per second, that's kind of the standard, so unless I get another thing that's going to tell me get out of meters per second, I'm going to stay here. And since that's given in meters, let's stick with it. Okay, assuming acceleration was 10 meters per second, that should be squared. Sorry about that. Squared. Acceleration is a negative 10 meters per second squared. So that just tells us it's slowing down. Okay, I'm writing this down. This is exactly what yours should look like. How fast was the car going? So how fast was the car going was showing what our initial velocity was before we stopped. So V naught equals question mark, and our units are going to be in meters per second. Okay, so those are the things that I do know. Because this is the second part of the question. I don't care about it yet. I'm going to leave it alone. So I have these things. Okay, I'm looking for V naught. I know acceleration. I know velocity initial. I know distance. So where am I going to find the information? How am I going to be able to plug it into an equation? Okay, you're given the kinematics. So here's what I do. I have the kinematics written down somewhere. I use yours. Okay. Yeah, I remember them half the time, but there's a lot of things to forget. There's a lot of things to screw up sign-wise. So just have them written down. It's okay. It's not the end of the world if you forget these. Just have them. Know where they're at. So I've got these written out. I'm going to put them right here. We can still see them. And we're going to go through the kinematics, and we're going to figure out which kinematic we need to use, which one best fits our variables. Okay. So the first one has velocity 1, which is our velocity final, equals velocity initial, which is what we're looking for. We're looking for initial velocity. That's handy. We know that. We know that. We know acceleration. We do not know time. Actually, I'm going to pull this up a little bit quicker so you can see it really well. Okay. We don't know time, so that doesn't work. Done. We forget it. We leave it. Okay. The next one, distance 1. Okay. We know a distance 1 because we went 22. Started at 0, so that one still works. 1/2, our change in velocity. We don't know the change in velocity. We don't know time. 2 variables we don't know, so guess what? It doesn't work. Okay, this next one, also a distance one. Could work because we know distance initial or distance final. We know our distance initial is 0, so here's our change in distance here. We have a initial velocity, which is what we're solving for. That works. We know we have our acceleration here. We know that. That's good. But this one has time. Again, 2 variables that we don't know, so it doesn't work. So that leaves us with one equation. Let's make sure it works and we didn't screw something up or need to find more information. Our velocity final squared. We know that. Our velocity initial squared. We don't know that, but we're solving for it. 2 times the acceleration. We know acceleration. And we know change in distance. So that's the equation we're going to use. So what I'm going to do is on my sheet of paper, which is going to be on my test, I'm going to write the equation. I'm going to write it nice and neat. I'm not going to write it goofy. I'm not going to just put it randomly throughout my problem. I'm going to put it so it's neat and visible. Okay? That's the equation parts. You get points for putting the equation in there. So make sure you have an equation in there somewhere. Okay. Our next part is our substitution. We're going to substitute the numbers in there. So V1 is 0. So guess what goes there? 0. Now it's squared. So the square keeps it 0. Awesome. I'm not going to put units there because there's no reason to put units because it's 0. V naught. So this is our initial. This is what we're solving for. So V naught squared is what we're solving for. We're going to leave that alone. Okay. Plus 2a. I come over here. I find out what a is. A is a negative 10 meters per second squared. How many a's do I have? I have 2. So what I do is I typically just take whatever my a is, I multiply it by 2 in my head because 2's are easy. And this is a negative 20 meters per second squared. Okay, it doesn't touch anything with the units because that's a multiply by 2 and not square. Okay. And then we have our delta D, and our delta D in this case is 22 meters. And that's a positive. Okay, so if you look at that, what I've done is I have shown givens, I have put an equation in, and then I have substituted my equation. Okay, so far I've made sure all my units are correct. I don't have anything that's crazy off. I have meters all the way across, and I have seconds. Even though my acceleration is second squared, the seconds will take care of themselves here in just a little bit. Okay. We are solving for V naught, not V naught squared. That's going to screw some of you up. So we want to make sure that we take care of units like squaring here in just a little bit. But let's get the other things to the other side of the equation. This is pretty easy. It's kind of tricky at first because we have a plus and negative. So since we have a plus and negative, that just means that this whole thing is negative. So if I have a negative there, that means when I put it on the other side, all I'm doing is the opposite function. So this is essentially a negative 20 times 220, which is 440. I'm adding it to the other side, so I have 440 meters per second squared. Now when I multiply the meters per second squared times a meter, that makes it meters squared per second squared. Okay. And that equals our V naught T, or V naught squared. Okay. We are going to now take this V naught. We don't want the square. How do we get rid of squares? We take the square roots. Have to do both sides. Okay, that's going to knock these out from meters squared and second squared to meters per second, which is our velocity unit. Awesome. And 440 is roughly 21 meters per second, and that is our velocity. So I've shown work. This is my steps. Here's my answer. Now here's what I want to do. I want to make sure I box that off. I want to circle it. I want to say, hey, Mr. Brewer, this is what my answer is. Okay? By you showing me not having to hunt for it, that's going to give you bonus points. That's going to be like, hey, Mr. Brewer, I know where the answer is. I know how to find it. And I say, thank you. Okay. So we've got it boxed off. We have answered part 1 of the question, which is how fast was the car going? And the answer is 21 meters per second. Okay. Part 2. Was the car exceeding, meaning was it going faster than the 20 or the 80 kilometers per hour speed limit? Now here's where some of you have the questions of, well, how do I get that into those units because those don't match up? Or you will say no because it's going 21 and you'll get it wrong. So let's take a look to see here. We have different units, so we have to convert. Now remember, anytime we convert units, we do dimensional analysis. Now since we need room for this, I'm going to go ahead and I'm going to slide it over to the board over here. Maybe. Okay. So I start with what I know. And what do I know? I know 21 meters per second. Since it's a two-level dimensional analysis problem, I put it into its two levels. Now, could I use the 80 kilometers per hour and convert that into meters per second? Absolutely. It's just going to be the opposite way now. Okay, so either way would work. We just got to find out which one's greater. So, 21 meters per second. I draw my little dimensional analysis brackets. Okay, if meters is on top, how do I get rid of it? We put it on the bottom. Okay, what do we want to go to? We want to go to kilometers. So we put kilometers on the top. How many meters are in a kilometer? There are 1,000 meters in 1 kilometer. Okay, so meters cancel out, and we're left with kilometers. Now we have seconds on bottom. What do we want to go to? We want to go to hours. So seconds on bottom, now we put second on top, and we have a conversion from seconds to hours, which is 3,600 seconds equals 1 hour. Okay, so again, I'm showing more work. This is showing how you convert. I didn't pre-work this one out. But we've got 21, and essentially we're multiplying it by 3.6 because 3,600 divided by 1,000 is 3.6. And that tells us that we are going 75.6 kilometers per hour. So, part 2 says, was the car exceeding the 80 kilometers per hour speed limit? No, we're going 75.6 kilometers per hour. So I would want to write no. We are going 75.6 kilometers per hour. So I actually answered it. So again, we get more points for that. This proves that we weren't going faster because we actually did the math with it. Okay? I go back, I box this answer. Okay? Things that are going to give you points that I'm going to be looking for now that they're boxed. Just write the units. Okay? Is it the correct number? I'm going to get that a little bit closer so maybe you can see that. Is it the right number? Okay, sometimes you guys answer it correctly in one part of the problem, but not at the point where you answer it. You'll get most of the points if you do that, because I understand sometimes you screw things up like that, but you know how to do it. Okay, that's why they're worth 20 points. So if you screw something little up, I can give you just -1 or -2, but if you screw up big things, it's going to be worth tons of points. Okay, so that's what I'm looking for. That's kind of how I grade them. That's what I go about looking for. What are you doing? What are you plugging in there? And that's how you get your points. So, you've got a test coming up on Friday. Make sure you're doing those little things, and you should be fine.